Hey Ashton, this is a... ignore the YouTube notification, what the heck? This is a special right triangle. This is one of the two types out of the 45, 45, 90 and 30, 60, 90. Can you guess which one it is? I wonder if the 45s make it obvious or not. Alright, so we're tasked here with finding the side lengths of the other sides. We have the hypotenuse, and we know this is the hypotenuse because of the little arrow that points to it, remember? And so, oh no, I don't want it. Okay, so we know that we have this, the hypotenuse side, and we know that there's a relationship between the hypotenuse and here. So what we want to do is find out how to get that. So what we do is we remember that our hypotenuse length is 5. And to get to the side length, whenever we do stuff, we have to divide by root 2. So, let's do that. 5 divided by square root of 2. A lot of people would think that it would just equal 5 root 2, but that is incorrect because that is what it would be if we multiply. So, to divide it, well, how do we divide by a square root? We don't want a decimal that just ends up repeating over and over and over. So, we keep change flip. This is the stuff with like fractions and stuff. So, we put the 5 over 1 and we keep it the same value. Now, for the division, we get rid of it. Why do I keep clicking on the ad? We keep the 5. We get rid of the division and change it to multiplication. And then we also get rid of the square root of 2. So we can flip it and put it at the bottom, then put it over 1. So 5 times 1 equals 5 over 2. Well, it's 1 times the square root of 2, which is just square root of 2. Well, now we have a bit of a problem here. So, we technically aren't supposed to have square roots in the bottom fraction, the denominator. So, we have to multiply it by what our math teacher calls a giant 1. But we have to multiply it by the same value of each fraction. Top. So, the 5 is getting multiplied by the square root of 2. And the bottom is getting multiplied by the square root of 2. This doesn't change the value of this fraction. It's still the same divided by the same, it's just a little bit bigger. It still holds the truth. If we were to just multiply the top by square root of 2, that would be a different number, and we don't want that. So when we do this, well, as I said earlier, when you multiply 5 by square root of 2, you get 5 root 2. And now, here's the higher level thinking. Square root of 2 times the square root of 2. Well, isn't that just the square root of 4? Wait, isn't that one of our perfect squares? Yeah, that is. So we could turn our square root of 4 into 2. So our answer here is 5 square root 2 over 2, which is our side length. That looks ugly, I'm sorry. Square root 2 over 2. There we go, good enough. And so that's how you do that for a 45, 45, 90 triangle. Now let's try something else here. Now if we were to get 45, 45, 90 triangle, but we weren't given the hypotenuse. Instead, given the side length, what do? We multiply by the square root of 2, because that's how we get it. First, I want to ask another question before we even attempt to solve for x. What is this value? What is this y value? This side is congruent to this side, which means that they are the same length. So y is also 3. So we just have to worry about the x. So we multiply by square root 2. And 3 times the square root of 2. As I told you on Only Prep, these two are variable. It would be like subtracting 2y from 3x. You can't do that, even though there's a 3 right here, there's a 2 right here, there's still the x and the y, and we can't do anything about it. The square root right here acts as our x or our y. It changes the value of the number, and we can't multiply it directly because we don't want to get a repeating decimal. So what we do is we just 3 root 2, and we leave it as that. So x is equal to 3 root 2. Now I want to try a 30, 60, 90 with you. So in this one, we are given which side? Now, I told you on Only Prep Day that there's 3 different sides for 30, 60, 90. There is the hypotenuse that we know from the little angle, which is y. And then there are 2 sides. And they're named after the angle right here, the 30-degree angle. So we have to figure out what side is adjacent to the 30-degree angle and what side is opposite. Adjacent means next to, so this side goes right along the 30-degree angle. So this one is our adjacent side, which we are given the value for. This one is far away, and it has no corners of the line connecting to that angle. So it is the opposite. So we're given the value of 12 for the adjacent leg. Well, we have to remember our 30, 60, 90 triangle rules. Unlike the 45, 45, 90, there's different rules for each side. So we're given the leg opposite at 12. And let me double check here. As it says here, the hypotenuse is 2 times the shorter leg, and the longer leg is square root 3 times the shorter leg. Those are alternate names for the adjacent and the opposite. The adjacent leg is always going to be longer, and the shorter leg will always be the opposite leg. I don't know why, that's just how it is. And so we are given the longer leg in this equation. We see here that it's 12. And we need to find both x and y, so we need to find both of them. Well, we can try going to the Hypotenuse, right? No, because it doesn't have any connection with the longer leg. But the longer leg does have one with the shorter leg. The shorter leg is equivalent to how do I phrase this? If you multiply the shorter leg by the square root of 3, it will give you the longer leg. But we only have our longer leg, so we have to divide just like we did in the other problem. So 12 divided by square root of 3. We can't do that. So keep 12 is over 1. Change. We got a giant multiplication symbol that looks like a meatball. And we flip. The 3, square root 3 is now on the bottom. The 1 is at the top. So we get a 12 over square root 3. This is not our answer because we still have the square root in the denominator, and they don't like that. They say it's ugly. And so we have to do this thing called rationalizing the denominator. So we got our 12 square root 3, and we multiply it by our giant 1. Square root 3 on top of square root 3, which equals 12 times the square root of 3 over 3. This is our short leg value. So let's make that clear. The short leg is this one. So 12 root 3. That is really big and ugly. I'm sorry. 12 root 3 over 3. That is our short leg. And now that we have the short leg, aka the golden special child, because that's the one that has all the relationships. It's the social one. It's the one that everyone wants to be. Now, since we have him, we can get the hypotenuse. The hypotenuse is really simple. It's just double the value. So let's go back to our little whiteboard-esque thing. And so the value of the short leg, as we just figured out, is 12 to the square root of 3 over 3. So we multiply that by 2. 2 over 1. Shrink. This is a little big. I'm going to erase it. 12 times the square root of 3 over 3 times 2 over 1, technically, will equal what? Well, we can't multiply the square root directly, and we're not dividing here, and they're both on top the numerator, so we can just cleanly multiply this straight over. 12 times 2, well, we know that is 24. And we can't do anything with the square root of 3, so we just carry it over. Square root of 3, then we put it over 3. Wait a second. Doesn't 3 go into 24? Yeah, it does. Okay. So, we divide by 3. 8 times 3 is equal to 24. So, we'd make it 8. Get rid of the denominator since it's unnecessary. It's 8 root 3. Then, bam! Now we got the other side. 8 root 3. Wonderful. We did it.